Imagine, for just a second, that you're walking down a long, entirely empty hospital corridor.
Oh, wow. Setting the scene early today.
Yeah, I really want you to picture this. It's early in the morning, right? Like maybe 4:30 a.m.
The graveyard shift.
Exactly. Everything is just completely quiet. The overhead fluorescent lights are, doing that soft humming thing.
Right, casting those long shadows down the hall.
Yeah, and the floors have just been freshly cleaned, like polished by the night crew, so they're reflecting the sterile light almost like a sheet of glass.
I can literally smell the antiseptic just thinking about it.
Right. So you are walking toward the cath lab to start your shift, and as you're walking, you happen to look down at the floor.
Okay.
There are your footprints just slightly scuffed on the fresh wax. But then you notice something else.
Here we go.
Besides your own footprints moving in like perfect synchronization, there is a second set.
It's funny. Every time I hear this, you stop and look over your shoulder, right? You scan the empty hallway.
Naturally, you'd be terrified.
Right. But there is absolutely nobody there, just the hum of the lights. Yet, those footprints continue right alongside yours, heading toward the exact same heavy double doors of the cath lab.
I mean, it sounds like the setup to a ghost story or like a psychological thriller or something.
It really does.
But that second set of footprints belongs to something far more consequential than a ghost. I mean, it belongs to an entity that doesn't need a physical body or lungs to breathe or eyes to see.
Which is almost scarier in a way.
Yeah. But those invisible footprints belong to a system that can read, analyze, search, organize, monitor, and learn from mountains of complex medical information in real time.
We are, of course, talking about an AI agent.
Exactly. And this incredibly evocative imagery, it comes directly from a brilliant piece of writing by Muralidhar Rajetti. It was published in the Cath Lab Chronicles on August 21st, 2026.
And to really understand the massive implications of that specific imagery, we have a very clear mission for today's deep dive.
Yes, we do.
We are exploring a profound structural shift that is currently rewiring cardiovascular medicine. And honestly, it's a shift that serves as a blueprint for, well, every highly technical profession on the planet right now.
Yeah, because we are moving away from the era of AI as just a simple operational tool, right?
Precisely. We are no longer talking about advanced calculators or digital filing cabinets. We are entering the era of AI as a digital colleague.
A digital colleague. I love that term. And to really map out this transition, we're looking at a stack of incredibly relevant sources today.
It's a good sack.
It is. We have Rajetti's visionary essay anchoring our discussion, and we're pairing that with a hard look at the recent Tata Consultancy Services announcement.
Ah, yes, the ADD Agent Hub. That's a big one.
Massive. And finally, we are running all of this through, the filter of reality by analyzing the U.S. Food and Drug Administration's latest regulatory framework discussion paper.
The one on generative AI-enabled devices.
Right, which literally just dropped on August 18th, 2026. So it's fresh. Our goal is to unpack the mechanics of what it actually means for a human professional to work alongside an intelligent system rather than just, operating a machine.
Because that distinction, the difference between operating and collaborating, it entirely redefines the fundamental architecture of the workplace.
It really does.
I mean, it changes the regulatory environment, the burden of liability, and frankly, the daily cognitive load of the human professional.
So whether you are scrubbing into a surgery this morning or managing a global supply chain or writing software architecture, this shift is already intersecting with your daily life.
It's unavoidable at this point.
Truly. Understanding how to collaborate with agentic AI without surrendering your own human judgment, your own critical thinking, it's the defining professional skill of this decade.
Absolutely.
So let's step through those double doors into the cath lab and look at how we got here.
Well, to truly measure the velocity of this current AI revolution, I think we have to look at the baseline of innovation in cardiovascular medicine first.
Right, because it's not like the field has been stagnant.
Far from it. The catheterization laboratory is essentially a pressure cooker for technological advancement. I mean, it is a room where physics, fluid dynamics, and human biology all intersect.
That's a great way to put it.
And historically, cardiovascular professionals are not strangers to massive technological upheaval. Their workspace has been in a state of constant aggressive evolution for, what, the last 50 years?
Yeah, Rigetti points this out in his essay. He notes that the generations of doctors before us experienced their own quantum leaps.
Oh, for sure.
Like, take the visual space, for example. Doctors used to rely on physical sign film to capture moving images of the heart.
Which is wild to think about now.
Right. They were literally dealing with chemical processing, hanging transparent sheets up to a light box, squinting to see the blockages in a coronary artery.
And then came the leap to fully digital imaging,
Yes, digital subtraction angiography.
where computers just remove the bones and dense tissues from the image to leave only the blood vessels filled with contrast dye.
Which feels like magic, honestly.
It does. But the mechanics of that shift alone required an entirely new understanding of image processing. But, the field pushed even further.
What came next?
We moved from simply taking two-dimensional shadows of blood vessels to actually putting cameras inside the arteries.
Okay, wait. Inside the arteries.
Yes, intravascular ultrasound, or IVUS. It involves threading a tiny catheter equipped with piezoelectric crystals into the heart.
Piezoelectric crystals, that sounds incredibly sci-fi.
It really does. But basically, those crystals emit high-frequency sound waves that bounce off the arterial walls.
Okay. Like sonar.
Exactly like sonar.
Yeah.
And it creates a cross-sectional map of the plaque. So doctors weren't just looking at the silhouette of a blockage anymore.
They were looking at the internal structure of the vessel wall itself.
Precisely. And even sound waves weren't enough eventually.
Of course not. Why stop there?
Right. So they introduced optical coherence tomography, or OCT, which swaps the sound waves for near-infrared light.
Light. Inside the artery.
Yes, the light measures the backscatter from the tissue. And that gives doctors a resolution 10 times higher than ultrasound.
That's just mind-blowing.
They can literally see the microscopic fibrous cap on a piece of cholesterol plaque. They can determine if it's about to rupture and cause a heart attack.
Wow. And that's just the imaging side of things, right?
Exactly. Beyond imaging, you have physiological assessments like fractional flow reserve.
Which does what exactly?
It measures the exact pressure drop across a narrowing in the artery. So instead of just guessing if a blockage is bad, it determines if it actually restricts blood flow enough to require a stent.
So it's incredibly precise.
Very. And then you add to that a relentless pipeline of new structural devices, like transcatheter aortic valve that can be deployed inside a beating heart without opening the chest.
Without even opening the chest.
Right. Or bioresorbable scaffolds that prop open an artery and then literally dissolve over time. The influx of new technology altering patient care is just unending.
Okay, let's unpack this for a second because we need to really analyze the underlying dynamic of all those incredible advancements.
Let's do it.
A doctor using an OCT scanner to measure backscattered light inside a human heart that is performing an act of breathtaking complexity.
Without a doubt.
But Rigetti draws a sharp, definitive line between all of that historical innovation and the AI revolution we're facing today.
He does, and it's a crucial distinction.
Because no matter how advanced the OCT scanner is, no matter how complex the algorithms are that process that near-infrared light into a visible image, the scanner is still fundamentally just a tool.
Exactly.
The human operator decides when to turn it on, where to point it, and how to interpret the screen. The machine does not act independently.
The dynamic is entirely unilateral. The human provides the input, and the machine provides a direct corresponding output.
Right. If the doctor's hand stops moving the catheter, the machine stops capturing new data.
The tool relies entirely on human momentum. It has no agency of its own.
So this sounds to me like the difference between upgrading from a basic scalpel to, say, a laser scalpel versus suddenly having a robotic surgical assistant whispering in your ear.
That's a really good way to frame it.
Like one is a better tool, but the other is a new dynamic entirely. If I have a state-of-the-art sports car, I am operating a brilliant machine.
Sure.
The suspension, the fuel injection, the braking system, they all do complex things, but only in direct response to my foot on the pedal and my hands on the wheel.
Right, you are the sole driver.
But if I get into a fully autonomous vehicle, the dynamic changes. The car is suddenly reading the environment, anticipating the traffic, deciding when to brake, and planning the route.
Which is a huge mental shift.
Exactly. I am no longer operating the vehicle. I am supervising a system that is operating itself.
And that structural change in the relationship is exactly what we are seeing in the Cath Lab and beyond right now.
The AI agent is the autonomous car.
Yes. An AI agent is not waiting for your foot on the pedal. It is designed to anticipate the workflow, organize the environment, and support the objective without requiring microscopic step-by-step instructions for every single action it takes.
But, I mean, this introduces a massive psychological hurdle, right? Which Rigetti confronts head-on.
It does. It's terrifying for a lot of people.
Because if the machine is anticipating and organizing independently, does collaborating with the system mean the human professional is surrendering control?
That is the million-dollar question.
Because when dealing with human biology, giving up the driver's seat feels incredibly dangerous.
Of course it does. But the boundary line here is absolute. The human retains ultimate, undeniable clinical responsibility.
Okay, so they aren't giving up the driver's seat.
Not at all. We're not talking about an AI agent scrubbing in, grabbing a scalpel, and taking over the physical procedure.
Thank goodness.
Right. We are talking about the delegation of information management. The AI agent manages the incomprehensible volume of data that informs the human's physical and clinical decisions.
So the human is not surrendering control of the patient.
No, the human is offloading the cognitive burden of data synthesis.
Okay, I see. So the agent isn't deploying the stent.
No.
It's analyzing the patient's 10-year medical history, cross-referencing it with real-time lab results and thousands of similar peer-reviewed cases.
Exactly, all in seconds.
And presenting the doctor with a highly organized brief on why a specific stent might be mathematically optimal, but leaving the final physical decision completely in the doctor's hands.
Precisely. It's a digital colleague doing the heavy lifting research.
Duh.
And to understand the mechanics of how that actually works in practice, we have to look beyond the theoretical essays.
Right. We need real-world examples.
We have to examine the actual software architecture being deployed in the enterprise space today. Which brings us to the recent announcement from Tata Consultancy Services.
Ah, the TCS announcement.
Yes, which really serves as the real-world anchor for Rigetti's futuristic vision.
Because TCS just unveiled a platform called the ADD Agent Hub. And their target isn't, generating creative writing or making deepfake videos.
No, they're going after the hard stuff.
They are pointing this platform directly at some of the most complex, highly regulated, and data-heavy domains in existence.
Drug development, clinical trials, and pharmacovigilance.
Pharmacovigilance, that is quite the word.
It is, and it's a particularly fascinating application for this technology.
What is it exactly, for people who might not know?
It is the science of collecting, monitoring, and evaluating information from healthcare providers and patients on the adverse effects of medications after they have been licensed for public use.
Oh, so it's like a massive global dragnet for safety signals.
Exactly. It's looking for the needles in a worldwide haystack.
And TCS is touting specific capabilities for the Agent Hub in these spaces. They are bringing AI agents into study design, the digitization of clinical protocols, clinical data review, and medical monitoring.
And to grasp the significance of what TCS is doing, we have to dissect the fundamental difference between the AI we use today and the agentic AI they are building.
Okay, let's break that down. Agentic versus conversational.
Right. Most people interact daily with conversational AI, specifically large language models.
Sure, the chatbots.
You open a chat window, you type a prompt, say, write me an email summarizing this meeting, and the model predicts the most statistically likely string of words to answer your prompt.
Right, it's very transactional.
It is a linear one-to-one interaction. It is prompt and response.
You ask for a recipe, it gives you a recipe. It doesn't go to the grocery store, buy the ingredients, and turn on your oven.
That's a perfect analogy. But agentic AI changes the architecture entirely. It moves from simple text generation to goal-oriented action.
Goal-oriented, so not just a prompt.
Exactly. You don't ask it a question, you assign it an objective. Under the hood, an AI agent utilizes a framework often referred to as REACT.
REACT.
Yes, reasoning and acting. When given an objective, the agent pauses to reason about the steps required to achieve that goal. It literally forms a plan.
Wow. Okay, so it maps it out first.
Then it takes an action. Perhaps querying a database, running a script, or reading a document.
And then what?
It observes the result of that action, reasons about whether the result brought it closer to the goal, and then takes the next action based on that new information.
So it has an internal logic loop. It's evaluating its own progress.
Exactly. Let's apply that to the TCS use case of digitizing a clinical protocol.
Let's do it. What does a clinical trial protocol even look like?
It is a massive, incredibly dense document, sometimes hundreds of pages long, detailing exactly how a medical study must be conducted.
Hundreds of pages, just for the rules of the study.
Yes. It outlines the schedule of assessments, the exact times blood must be drawn, the specific criteria a patient must meet to be included.
Okay, so if you ask a standard chatbot to digitize that,
It might just give you a flimsy bullet point summary. It wouldn't know what to actually do with the information.
but an agentic system approaches that same 100-page document differently.
Entirely differently. Its objective is to build a functional digital architecture for the trial.
Okay, so how does it start?
First, it reads the document to identify the schedule of assessments. It extracts those timelines and interfaces with the hospital's calendar software to actually build a schedule.
It builds the schedule itself.
Well, then it analyzes the inclusion and exclusion criteria, translates those medical requirements into database queries, and runs those queries against the hospital's electronic health records to find potentially eligible patients.
Without a human clicking search.
Right. And as it's doing this multi-step process, it might encounter a contradiction.
Like what? What kind of contradiction?
It might see that the protocol requires an MRI on day 3, but the hospital's internal guidelines prohibit that specific MRI contrast dye for patients with a certain kidney function level.
Oh, wow. So a conflict between the trial and the hospital rules.
Exactly. So the agent pauses its execution, flags the contradiction, and sends an alert to the human trial manager saying, I am building the schedule, but I found a critical regulatory conflict on day 3 that requires your human judgment to resolve.
That is, that ability to flag issues without being explicitly prompted to look for that specific conflict, that is the hallmark of the digital colleague.
It absolutely is. It is executing a long-term workflow, managing multiple interconnected tools, and returning to the human only when it encounters an obstacle that requires a level of executive decision-making it does not possess.
It is not replacing the trial manager. It is acting as a force multiplier for the manager's cognitive reach.
A huge force multiplier.
I want you to think about your own daily workflow. Let's say you manage a team of financial analysts.
Good example.
Imagine assigning a quarterly review to a digital colleague. It pulls the raw data from your internal servers, scrapes the relevant market data from public financial filings, cross-references everything against the new SEC compliance rules that were just updated last week.
Doing the work of 5 people, basically.
Right. And then it builds the preliminary financial models and then flags 3 specific anomalies in the cash flow statements that don't match historical trends.
And hands it to you.
Yeah, it hands you a completed dashboard and points directly to the 3 things that actually require your 20 years of financial expertise to understand.
The shift from searching and gathering to reviewing and deciding represents a fundamental economic shift in how we deploy human intelligence.
It really does. It changes what we value in an employee.
And in cardiovascular medicine, as Rajetti points out, this shift isn't just a luxury, it's a structural necessity to prevent the system from collapsing under its own weight.
Which brings us to a massive focal point in the source material, clinical trials. Why is this specific environment so desperate for agentic AI?
Because cardiovascular medicine is an engine that runs almost entirely on clinical research. Every single decision made in a cath lab is backed by mountains of empirical data generated by global trials.
The scale of this research ecosystem is just staggering. Think back to the innovations we discussed earlier.
Right, the stents, the valves.
Every minor iterative improvement to a drug-eluting stent must be tested. If a company develops a new bioresorbable polymer coating to deliver medicine from the stent into the artery wall, they cannot just start putting it in patients.
No, the FDA would have a field day.
Right. They have to prove it is safe, that it is effective, and that it is statistically superior, or at least non-inferior, to the current standard of care.
And designing a trial to prove that requires enrolling thousands of patients across dozens of hospitals globally. You have to answer hyper-specific questions.
Like, does this new polymer work for diabetic patients?
Does it cause adverse reactions in patients over 70?
Does it fail if the artery is heavily calcified?
Exactly. And generating the answers to those questions requires tracking an ocean of variables. The data footprint of a single patient in one of these trials is immense.
Walk me through that. What does that footprint look like?
Well, you begin with the screening process.
Mm-hmm.
A patient's electronic health record is reviewed against dozens of strict inclusion and exclusion criteria.
Okay, so past medical history.
Current medications, baseline blood work, previous imaging studies, they're all logged.
Right.
If they're enrolled, the exact procedural details of their stent implantation are recorded. The pressure used to inflate the balloon, the length of the stent, the duration of the procedure.
And then that's literally just day one.
That's just day 1. The real data deluge happens in the follow-up phase. The trial protocol might require follow-up visits at 30 days, 6 months, 1 year, and 5 years.
And at every single touch point, new data is generated.
Electrocardiograms, stress tests, lab panels, reports of any new chest pain or adverse events.
So multiply that single patient's data by 10,000 patients across a multi-year global trial, and you have an information ecosystem that is fundamentally hostile to human processing capabilities.
Hostile is the right word.
And here's where it gets really interesting. Rigetti hits on a profound insight regarding this data burden.
Yes, the attention versus speed argument.
Exactly. In the tech world, the primary metric for automation is almost always speed. We measure how many milliseconds it takes an algorithm to process a data set compared to a human.
But in healthcare, the speed of the output is secondary to the quality of the attention applied to the input.
Rigetti argues that the true advantage of the digital colleague is not saving time, but saving attention.
Because human attention is a finite, biologically constrained resource. It is the single most valuable currency in a hospital.
It really is. A brilliant, world-class cardiologist has a hard biological limit on how much dense information they can parse before their cognitive function degrades.
We refer to this broadly in medicine as cognitive fatigue, or more specifically in data-heavy environments, alert fatigue.
Alert fatigue. Paint a picture of that for me. What does that look like?
Imagine a clinical trial coordinator. They spend 8 hours a day cross-referencing complex patient charts against dense protocol documents.
Okay, sounds exhausting.
It is. By the 50th chart of the day, their neural pathways are just exhausted. Their eyes scan the words, but the comprehension drops.
They're just glossing over it.
Right. They might miss a subtle interaction between a patient's obscure autoimmune medication and the trial's exclusion criteria.
And what happens if they miss that?
That single missed detail could result in an adverse event for the patient and completely compromise the integrity of a multi-million-dollar trial.
So it's the classic problem of finding a needle in a haystack, but the human is forced to examine every single piece of hay individually.
Yes. But a machine, however, does not suffer from a mid-afternoon slump.
No, it doesn't need a coffee break.
An agentic AI evaluating the 10,000th patient file applies the exact same mathematical rigor and granular focus as it did to the very first file. It does not get bored.
It does not get distracted by a pager going off down the hall.
Exactly. So by offloading the tasks that require massive amounts of attention but minimal high-level judgment, the AI recalibrates the human's role entirely.
I see. Because finding a missing signature on a consent form or verifying that a patient's creatinine clearance is above a specific threshold, that requires attention, but it does not require a medical degree.
Right. But synthesizing all those disparate data points to determine if a patient's sudden shortness of breath is a benign side effect or a life-threatening complication of the experimental device.
That requires the accumulated judgment of a seasoned professional.
Exactly. So if the AI is managing the hay, the doctor is free to actually examine the needle.
The professional gets to step out of the grueling work of data administration and return to the work of clinical interpretation.
Which creates a paradigm where the physician can allocate their finite cognitive resources toward patient interaction.
Which is what they want to be doing anyway, right?
Absolutely. Instead of spending 20 minutes before an appointment frantically clicking through an unorganized electronic health record, trying to piece together a patient's complex history, the doctor reviews a highly synthesized, perfectly organized briefing generated by the agent.
So they walk into the exam room with their full attention directed at the human being sitting on the exam table.
It's a game changer for patient care.
Now, that vision of the future is incredibly compelling. It solves the burnout crisis. It solves the data overload problem. But it hinges entirely on a single fragile concept.
Trust.
Trust. The doctor walking into that exam room is making life-or-death recommendations based on the briefing prepared by their invisible digital colleague.
Yes.
If the agent hallucinates a lab value or silently drops a crucial piece of medical history from the summary, the doctor's subsequent judgment, no matter how brilliant, is fundamentally flawed.
Garbage in, garbage out. Which brings reality crashing back into the conversation.
Yeah, we have to talk about the regulators.
We do. The transition from theoretical potential to clinical deployment is governed by strict, unforgiving regulations. We cannot deploy an AI agent in a hospital based solely on the promises of a tech company's marketing department. The regulatory bodies recognize the existential risk of relying on opaque algorithms for clinical decisions.
This is exactly why the August 18th, 2026 FDA discussion paper is such a pivotal moment in this timeline.
It really set the stage.
The FDA is actively trying to construct the regulatory architecture for generative AI-enabled medical devices before the market is flooded with unproven tools.
Which is a monumental task. They are tackling how to regulate systems that are fundamentally designed to act autonomously and learn continuously.
Because historically, the FDA regulates medical devices by evaluating a static product, right?
Right. When a company submits a new titanium hip implant for approval, the FDA tests that exact physical design.
Okay.
Once approved, the manufacturer cannot change the dimensions of the implant without submitting a new application. The device is locked.
It's a known fixed entity.
Exactly. And early machine learning algorithms in medicine were treated similarly. An algorithm designed to detect pneumonia on a chest x-ray was trained on a specific data set, its weights and biases were locked, and it was evaluated as a static tool.
So if it performed accurately during the test, it was approved.
And it didn't change after it was deployed.
But agentic systems built on generative foundation models are not static.
No, they are fluid. Their entire value proposition is that they adapt to complex, unstructured environments.
So if an agent is managing clinical trial workflows, it is interacting with dynamic, constantly shifting variables. How do you even begin to regulate a system whose behavior is inherently unpredictable by design?
It's the challenge of the decade. The FDA discussion paper addresses this through concepts like predetermined change control plans, or PCCPs, and rigorous post-market surveillance.
Okay, so they have to agree on how it's allowed to change beforehand.
Basically, yes.
Uh,
But at the core of the FDA's approach, and the central theme Rigetti highlights, is the absolute necessity of the audit trail.
the audit trail.
Yes, if a system is going to operate dynamically, its internal logic must be completely transparent. We must be able to solve the black box problem.
Okay, let's talk about the black box problem, because healthcare cannot simply say, the tech can do it, so let's use it. We have to ask, can we trust it? The black box problem being the reality that right now we often don't know exactly how a neural network arrives at a specific conclusion.
We really don't. It's a web of probabilities.
Right. We feed data in, we get a highly accurate answer out, but the billions of mathematical calculations that happen in the middle are largely impenetrable even to the engineers who built the system.
Which is fine for consumer tech.
Right. If Netflix recommends a movie I hate, the stakes are zero. But if a medical AI agent recommends a fatal drug dosage, the stakes are absolute.
So Rigetti outlines the strict parameters of what an AI audit trail in healthcare must look like. It requires a level of data provenance that borders on the cryptographic.
So it's heavily documented.
Extremely. When an AI agent reaches a clinical conclusion, it must provide a transparent, step-by-step ledger of its reasoning.
Let's break down those steps practically, because this is where the rubber meets the road.
Let's do it. There are basically 4 key steps to this audit trail.
Okay, what's first?
First, the audit must show exactly what information the AI used to begin its task.
Okay, so source verification.
Right. Did it pull the patient's records from 2024? Or did it accidentally access an outdated file from 2018? That distinction is critical.
Obviously.
And second,
what specific steps did the agent take in its react loop? Remember the reasoning and acting we talked about?
yeah, so tracing its path. Did it search the hospital database, query an external medical journal, and then cross-reference a pharmacy system?
Exactly. You have to see its footprints, to use our metaphor.
Nice callback. And third,
What did it find during those steps? And critically, what did it miss?
oh, what did it miss? That's huge.
Yes. Did it successfully extract the patient's allergy to penicillin, but fail to extract their history of mild asthma because the note was buried in an unstructured text field?
That unstructured text is a nightmare for AI sometimes, so you have to know its blind spots. And the fourth step.
Why did it reach its conclusion? This requires explainable AI, or XAI techniques, where the model outputs the specific weights it applied to the data.
So it can't just give an answer, it has to show its math. Yes. It must state, I flagged this patient as a high risk for bleeding because I heavily weighted the interaction between their age, their recent prescription for a blood thinner, and their history of a minor ulcer 3 years ago.
Okay, that makes sense. And there's one final piece of the audit trail, right? Was a human involved? And what happened afterward?
Crucial point. Did the human review the agent's logic path, sign off on the risk assessment, and proceed with the procedure?
Because if we look closely at this requirement for transparency, we realize that it mirrors existing practices in clinical governance.
It really does.
Yeah.
Healthcare is already an industry built on massive frameworks of accountability.
Like, a surgeon doesn't just operate and go home.
No. They write a detailed operative note documenting every physical step they took. They record the lot numbers and serial numbers of every implant used.
So if a patient develops an infection a month later, the hospital can trace that infection back to a specific batch of sterilized instruments used on a specific day in a specific operating room.
Exactly. The FDA is essentially demanding that AI developers build that exact same level of traceability into their code.
But let me challenge this for a second. If an AI makes a subtle error in patient eligibility for a trial, and that error isn't caught for 6 months, who is accountable? The doctor, the AI developer.
That is the messy frontier of medical liability right now. But the regulatory body must be able to open the digital ledger, pinpoint the exact node in the algorithm's logic loop that failed, determine if the training data was biased, or if the human operator failed to properly supervise the system's output.
So accountability cannot evaporate into a black box.
It cannot. If an AI agent cannot generate a comprehensible audit trail, it is fundamentally incompatible with the ethical and legal standards of modern medicine. It simply cannot be deployed.
The ability to trace failure is the prerequisite for trust.
Beautifully said.
Which brings us to the psychological impact all of this has on the human workforce.
Oh, this is the part that keeps people up at night.
We are introducing a technology capable of executing complex, multi-step workflows. We are building massive regulatory frameworks to govern its behavior. We are shifting the economic value of human labor from data gathering to executive judgment.
It's a total paradigm shift.
It is completely natural for a highly trained professional to look at this landscape and feel a profound sense of anxiety regarding their own relevance.
The fear of obsolescence is a powerful, powerful force.
Especially when you've spent your life training for something.
When a professional has spent decades mastering the intricate details of data administration, navigating complex electronic health records, and memorizing dense trial protocols, watching a digital colleague perform those tasks instantaneously feels like an existential threat.
But Rajetti addresses this anxiety directly in what I think is the most resonant part of his essay.
I agree.
He speaks to the modern professional and offers a pragmatic mantra: don't be afraid, be prepared.
It's so simple, but so accurate.
He contextualizes this moment by reminding us that the definition of work has been overhauled by technology countless times.
Right. Think about the introduction of the MRI machine in the late 1970s.
That's a great historical parallel.
It did not eliminate the need for radiologists. It exponentially expanded their diagnostic capabilities and created entirely new subspecialties.
So the people who adapted to the new technology didn't disappear, their roles simply elevated.
Exactly. The tool absorbed the lower-level tasks, and the human expanded their mastery into the new frontier created by the tool.
Rajetti reframes the nature of the threat in a very specific way. The danger we face isn't a science fiction scenario where an AI agent rolls into the Cath Lab on wheels, puts on a lead apron, and forcefully removes the doctor from the room.
As funny as that image is, no, that's not the threat.
The true danger is far more mundane and entirely self-inflicted. The danger is a human professional stubbornly refusing to learn how to communicate and collaborate with the AI.
Choosing to manually sort through the haystack while their peers leverage the machine to find the needles.
Yes, a physician who insists on spending 2 hours manually parsing a 100-page trial protocol will simply be outpaced by the physician who delegates that task to their digital colleague and spends those 2 hours interpreting the results and designing a better treatment plan.
The professional who refuses to adapt will not be replaced by an AI. They will be replaced by another professional who knows how to use the AI.
So, if we accept that collaboration is mandatory for survival, what does this new symbiotic workflow actually look like on a Tuesday morning in the hospital?
Rajetti breaks down this relationship beautifully, defining the new division of labor.
Okay, let's go through it.
First, the AI searches, we interpret.
Right. The AI organizes the chaos of the data. We decide on the clinical action.
The AI identifies a complex statistical pattern across 10,000 patient files. We ask if that pattern actually makes clinical biological sense in the real world.
The AI raises a concern based on an anomaly it detected. We investigate the context of that anomaly.
It is a continuous dynamic loop of delegation and verification. The agent presents a synthesized reality, and the human remains the ultimate arbiter of meaning.
And Rajetti argues that this dynamic doesn't create a weaker, lazier professional who is overly reliant on a digital crutch.
No, it creates a profoundly stronger professional.
By removing the cognitive friction of data administration, the human is free to operate at the absolute peak of their license.
They have more mental bandwidth to apply to empathy, to complex ethical considerations, and to the nuanced gray areas of medicine where algorithms fail and human intuition is required.
The narrative of the future is so often framed as a zero-sum war, like humans versus machines.
Right, Terminator style.
But Rajetti dismantled that binary entirely. The future is a clinician sitting at a workstation examining a patient's complex history with an AI assistant quietly managing the heavy lifting in the background. It is humans with AI.
That is the fundamental shift. Humans with AI.
Which brings us back to the image we started with. The empty hospital corridor, the fluorescent lights, the second set of footprints walking beside yours.
A little less spooky now, hopefully.
Yeah, much less spooky.
Yeah.
We have tracked those footprints from the historical evolution of the Cath Lab, where tools went from physical film to digital sensors, setting the stage for the leap from operating machines to collaborating with systems.
And we explored the architecture of that collaboration, looking at how platforms like TCS Agent Hub utilize React frameworks to execute multi-step objectives in drug development and pharmacovigilance.
Fundamentally differing from the simple prompt and response chatbots of the past.
We analyzed the crushing data deluge of modern clinical trials and how agentic AI acts as a shield against cognitive fatigue.
Saving our most finite and precious resource, human attention.
And we grounded the entire discussion in the regulatory reality established by the FDA's August 2026 framework.
Proving that the integration of digital colleagues relies absolutely on explainable AI and rigorous, transparent audit trails. Accountability remains the bedrock of medicine.
And we arrived at the realization that the professional of the future must evolve. We must shift from being processors of data to being judges of truth.
As we walk alongside these digital colleagues, Rajetti identifies the 3 essential skills that will define your value in the modern workforce.
This is the real takeaway here.
The most critical competencies you can possess are simply knowing 3 things: when to trust the AI's output, when to rigorously question its logic, and when to confidently say no to its recommendation.
Because the machine possesses an infinite capacity to process data, but data is not wisdom.
Exactly.
The machine can calculate probabilities, but it cannot understand the lived reality of the patient sitting in front of you. The human must remain the anchor of clinical meaning.
But as we close this deep dive, there is one final provocative question that arises from this entire paradigm shift.
It's a tough one.
We've established that the digital colleague will take over the foundational grunt work. It will sort the data, extract the criteria, and highlight the anomalies.
Right, saving all that time and attention.
But consider how the seasoned, masterful professionals of today built their incredible intuition in the first place. They built it precisely by spending thousands of hours slogging through that raw, unorganized data.
They did the grunt work.
They learned to recognize the subtle patterns because they were forced to look at every single piece of hay to find the needle. They made mistakes, they felt the cognitive fatigue, and their brains rewired themselves to spot the anomalies intuitively.
The struggle to process the data is often what builds the clinical judgment required to interpret it.
So if we offload the struggle to the AI, how will the next generation of doctors develop that vital intuition?
It's a real paradox.
If human judgment is our greatest remaining asset in the era of the digital colleague, how do we teach that judgment to a first-year medical student when the AI is already doing the very tasks we used to learn from?
It's a structural paradox we have to solve before the current generation of experts retires.
Keep an eye on your own footprints as you walk into the future.